Alder Lake is here. Alder Lake is Intel's newest processor as of the end of 2021. Up to 16 cores in the 12900K, but even more surprisingly, 10 cores in the i5. It's a new internal microarchitecture, and it's very different than anything Intel has ever done in the past. I've got a lot to tell you, and not a lot of time to tell you what I need to tell you, but also there's stuff that I'm going to tell you that is probably going to affect how you interpret information from other reviews. So there's a lot we got to talk about. All right, first up, about a week ago, I did a video on the Alder Lake announcement. There's a lot of information in that video. You should definitely go check that out. I don't want to really rehash a lot of information there, but the most important takeaways from that video are: one, we've got a new chipset. That's the Z690 chipset. We'll come back to that. And the internal layout of these processors is completely radically different than anything Intel has ever done. I don't think that the people that have come up with x86 and been working on x86, even in the recent past, ever thought something like this would be possible on an x86 desktop processor. We have big, powerful performance cores, and we have very small, very efficient efficiency cores all in one package. So Alder Lake, the 12900K, is 8 performance cores and 8 efficiency cores. So when you're doing something like rendering, all 16 of those cores will work together and deliver a great experience. For things like user interactive things, I'm going to run an interactive program. Those tend to focus on single thread performance and things like gaming. And so that mostly will end up running on the performance cores. There's Threadripper technology, which is a hardware assist with the operating system scheduler. There's some nuances with Linux. Be sure to check that out on the Level 1 Text Linux channel. There's a lot there. But there's also the 690 chipset. So we've got 16 lanes of PCI Express 5, 4 lanes of PCI Express 4 for the NVMe, and about 8 lanes of PCI Express 4 worth of bandwidth to the DMI, to the chipset. Now, if you're doing the math and you're looking at this and you're saying, wait a minute, we've got more PCIe bandwidth than we have main memory bandwidth? Basically, yeah, at least until DDR5 is a lot faster than it is today. We've got 64 gigabytes per second potentially on that PCI Express 5 interface, and then 8 gigabytes per second on the PCI Express 4 interfaces per group of 4 lanes. So there's 12 lanes there. That's almost 100 gigabytes per second in all of our I/O. Now, to be sure, I've done my testing. There are actually some internal bandwidth limitations on the ring that connects all of the cores on Alder Lake, which this is Alder Lake. This is Alder Lake too, but this is also Alder Lake. So it turns out that the L3 cache and the CPUs are all connected in this ring, and the big cores, there's 8 of them. Those are the performance cores. And the efficiency cores physically are actually extremely tiny. They're very efficient, not just in terms of power usage, but also in terms of like how much room they take up on the silicon. This is a model of what the silicon looks like actually inside the processor. You can see it's kind of rectangular. That's why this is a new socket, LGA 1700. It's not going to work with your old motherboards, not even a chance. Now, before we get into the benchmarks, there's something really important that you need to know. Everywhere you look on the internet, if you're trying to do the apples to apples comparison with Team Red, I'm talking about the AMD 5900X, the 5950X. 5950X is also a 16 core monster. There's a lot of talk about Windows 11 performance for AMD Ryzen and patches, and it's like, does Windows 11 perform correctly with the AMD CPUs? Windows 11, in a nutshell, still has some teething issues on the AMD platform. If you get everything set up exactly perfectly correctly for an AMD system, Windows 11 is about 3 to 5% faster on average for the modern gaming titles on Windows 11 versus Windows 10, just pure Team Red. When you throw Alder Lake in the mix, things are interesting because I don't think it's fair to run Alder Lake benchmarks on Windows 10 because, again, with Threadripper and because you've got cores that are not exactly the same, the cores have different capabilities. The Windows 10 scheduler was never designed to deal with that, and it puts Alder Lake at a disadvantage given that the scheduler in Windows 11 is available. In the past, when the shoe's been on the other foot, AMD kind of had cores that had different access to different memory with CPUs like the 2990WX. Those issues were never actually fixed. So if you run Linux, you're going to have a better experience with the 2990WX than you will with Windows, because Windows does some incredibly dumb stuff with the 2990WX, and I've shown that in a video. In fact, if you lie about the CPU topology to Windows, you'll get a better performance experience out of Windows all multi-core than you will without it. Of course, single core has a random chance to suffer in that case, so kind of darned if you do, darned if you don't. With Alder Lake, there are a lot of weird anomaly edge cases, even with Windows 11, especially when you're running older games. Now, de novo is the big one, and Intel is right in front trying to deal with that. So Intel is using their 800-pound gorilla status to bludgeon all game publishers that use de novo into fixing their de novo issues. So they tell us that as of launch, pretty much all the games out there that use de novo and have DRM problems with the Alder Lake platform, those issues have all been fixed. And I can tell you that anecdotally, my own experience, I have less issues on Windows 11 wringing the absolute maximum performance of Windows 11 out of Alder Lake than I do on the AMD Ryzen platform. To be sure, I don't think that reflects super badly on AMD. I think it reflects more badly on Microsoft because they've rushed out a beta product without really doing adequate testing, in my opinion. That said, you'll see things that say the performance regressions are up to 20%, and then you'll see other things that say the 20% performance regression is overstated. And actually, both of those things are correct. When you dig into it, there's a couple of things that are working together that sort of work to sabotage performance potentially. One of those things is Windows 11 has a built-in driver assist thing, so you can accidentally be in a situation where you've installed the latest GPU driver, and then Windows 11 helpfully installs the latest GPU driver that's on Windows Update, which is often older than the one that you installed. This seems to also happen with the chipset driver, and it also seems to happen in weird edge case situations, like you'll do DDU to do a clean driver install, and then install a new driver, and then everything is working correctly, and then you reboot, and everything has actually reverted to earlier performance. I don't know how many reviewers are going to be clued into that, but this is a day one problem, and you're going to have to take that into account when you look at benchmarks. So bottom line, what does that mean when we're trying to do performance comparison? It means that, one, as a consumer, I don't think a consumer is going to go through a lot of hoops to try to deal with this issue. I think we're going to ultimately have to see Microsoft or AMD write a utility that'll run a little diagnosis and be like, okay, green, you're good, or yellow, you may need to update some stuff, or red, something is wrong. And I don't think there's any avoiding that because the waters are so muddied now. Because like I say, the performance that I experience on Windows 11 is even better than Windows 10 generally on just about all, well, the average uplift is like 4 to 5%. There are some games that do regress a little bit on Windows 11 versus Windows 10, but on average, we're talking like 4, 5, 6%, somewhere in that neighborhood of performance improvement, just generally moving from Windows 10 to Windows 11 on AMD 5000 series CPU platforms. One of the reasons that I'm going on and on and on about these performance issues on a competing platform in an Alder Lake review is because I'm sure that no one has deliberately sabotaged AMD's platform. At least I don't think that the performance regressions that we're seeing rise to the level of something that could even be considered sabotage. The timing of these events is a little unfortunate. I mean, we are basically talking about a processor that's been out for a year versus a processor that just came out. And the processor that just came out, the performance is bananas. It is completely insane. Gaming performance as well as multi-core performance. Multi-core performance, I think, is less interesting than single-thread performance, and the single-thread performance is absolutely insane. That's an incredible engineering achievement, and it shows in games. If anything, things like faster memory and faster GPUs are only going to widen the potential gap. To see the biggest gap between the Alder Lake and competing CPUs, you need the very most expensive GPUs. We're talking 3090, and that's where I've got the MSI 3090 Supreme. That's what I use for pretty much all of my testing. I also have a Founders Edition 3090, and I had to use that as a stand-in for some additional testing, and we can get into the nitty-gritty of that, but it's probably not necessary. But the MSI Supreme 3090 is an insane air-cooled card that's super high clocked out of the box. It's insanely high performance. And in order to really accentuate the differences between the two platforms, you got to run it like 1080p medium. And I don't think anybody's really going to run a 1080p medium on Alder Lake when you can run it 4K buttery smooth 60 FPS plus encoding plus everything else. See, that's the magic of sort of juggling things between the efficiency cores and the performance cores. You can shove all the stuff like CPU transcode to the efficiency cores if you really want to, and games and everything else will juggle that. It honestly worked surprisingly well. For everything in this entire platform to be as new as it is, it was shocking how well everything worked. But let's get back to the game benchmarks. Our game testing here between Windows 10 and Windows 11 is a little bit abbreviated for this video. We actually did a lot more testing than you can see in this video, but we're already getting kind of long, and some of these things I want to revisit because there's some kind of anomalous behavior on both Team Red and Team Blue. So that's something that I can sort of juggle and deal with in a future video. But hey, new platform, new operating system, let's just change everything. What could possibly go wrong? Real frustrating. Woo, let's dive in and take a look at those Alder Lake benchmarks. Now the benchmarks this time around, you can make the benchmarks tell any story that you want, because this processor is different enough that you can sort of make it say whatever you want. So let's start with artificial benchmarks. Now let's start with Geekbench specifically. If we look at the single core score here, with a little bit of overclocking tuning, we can easily score over 2,000 points. We're close to 2,000 points as it is out of the box stock. That is a monstrous score. By comparison, our 5950X running at 5.05 gigahertz is about 1,700, give or take. That's a pretty respectable score, but there's a big difference between 2,000 and 1,700. But again, this is an artificial benchmark. And when we look at the multi-core score, our 8 performance cores and our 8 efficiency cores on the Intel side of the equation pulls ahead of 16 homogeneous cores on our 5950X. But if we switch gears and we look at CPU-Z, just running CPU-Z, okay, our single core score is still completely monstrous, but our multi-core score, the 5950X, leaps ahead. It depends on what your workload is and what you're doing as to whether or not 16 full cores can be bested by 8 performance cores, which have an insane single thread performance, and 8 relatively weaker efficiency cores. This really isn't a lot different, maybe a more refined approach from Intel from what AMD was doing with their chiplets, because we had, maybe there was one chiplet that was binned for the really high clock speed, maybe there was another chiplet on the 5950X that was binned for power efficiency, but we are talking about a 150 watt difference between the Intel part and the AMD part. So the AMD part really is doing astonishingly well when you consider that it's running at stock at about 95 watt TDP versus our Intel CPU, which can be demonstrated to be using 250 watts, give or take, for the PL2. So it's not really an apples to apples comparison in terms of power usage. Now, gaming performance gets a little interesting. When we've got our run-of-the-mill games like Shadow of the Tomb Raider, there's not really a lot of perceptible difference until Alder Lake generally is going to pull ahead in most gaming benchmarks, but there are still certain weird side effects from the mismatched CPU architecture that just has to be dealt with in the scheduler or in the operating system or in updates to the game. Windows 11 handles things a little better than Windows 10, but if you have a game that's bouncing back and forth between a performance and an efficiency core as you're playing the game, you definitely notice that. But I don't really see that as a showstopper. I think that's something that's going to get fixed really quickly. Now, some of our other game titles, Intel doesn't necessarily take first place, and really interestingly, it seems like our ASRock 6900 XT is pulling ahead of our NVIDIA 3090, and just in terms of raw performance on Intel's new platform, which is interesting in and of itself. If you have one takeaway from our video game benchmarking, it is that these results are actually kind of highly variable. It depends on the speed of the memory and the memory latency, the particular memory kit, and the high frame rate, sort of gaming artificially. I think it's much more realistic that if you're gaming on a system this high end, that you're going to be gaming at 1440p, a widescreen resolution, probably 4K. In those resolutions, the differences between the platforms really start to disappear. Other gaming results show that this Intel platform is not perfect. It's new. It's got some new teething issues, but it is really exciting because of the promise here. There's a lot of really clever engineering under the hood, but in order to take full advantage of it, the software still needs a little bit of love and attention. When you're doing mixed workloads like gaming and streaming, Alder Lake can make a lot of sense. You can do a lot of CPU encode, balancing the game and the stream between the performance and efficiency cores. It's going to be even less likely that your background CPU tasks interfere with the game because they're running on a different kind of CPU core. This has the potential to be really handy, but this also has a pretty solid iGPU, so you can just offload your encoding to the iGPU and then have your game on a dedicated GPU, and that also sort of kills two birds with one stone. That's also something to look for in other productivity benchmarks. It's, oh yes, this is so much better. And it's like, well, it's using the iGPU for that. It's not really using the CPU or the dedicated GPU, so because it's using the iGPU, of course it's doing that better. That's not a thing on the competing platform. But still, is that a better overall user experience? It depends on the program, depends on what you're doing. Adobe Suite, I'm looking at you. Now the i5 doesn't have quite as much headroom in terms of overclocking or in terms of just opening it up and letting PL2, sort of do its thing. But the i5 is really looking like it's the CPU this generation that should get most of the attention because 10 cores, $300, it's a media and content production champ. You can game with it. You can game at really high frame rates. It has a lower, we're talking 250 watts at the top end for the 12900K. The i5 is quite a bit less on the power scale, which means that it can potentially work well with, full turbo boost all the time on less expensive motherboards, but you can also overclock it a little bit, a fair bit. Maybe a little bit more than the 12900K. I don't know, jury's still out on that. The i5 is so interesting, I plan to do a separate video on just the i5 to show you some of the cool tricks that you can do with the i5 because you get a little bit more thermal and power headroom, I think, on it than you do with the i9. Depends on the board, depends on some other parameters, and I don't know if it's a DDR4 or DDR5 thing. I'm still investigating. But I think you're going to want to get engaged for that future video on the i5 because the i5 really does hold its own. Now you may be wondering, how does Alder Lake do compared to some of Intel's flagship systems in the past, like the W3175X, which is a workstation Xeon overclockable monster CPU, or even Intel, like the 10980XE, the last CPU that Intel's put out for the X299 platform, the high-end desktop platform. Does high-end desktop even make sense when we have something like Alder Lake? Well, the answer is Alder Lake makes both of these systems look fabulously antiquated by comparison. I mean, Alder Lake is 16 cores, but it's really 8 performance cores and 8 efficiency cores. This W3175X system stole the show at Computex in 2018. 28 cores, 5 gigahertz. Yes, it did require an active cooler. This is on the EVGA SR3 Dark platform. This CPU only entered general availability just about 2 years ago. I can overclock it on dual 360 radiators to just about 4.5, 4.6 gigahertz on 4 to 6 to 8 cores before power delivery and heat become a problem. Similarly, on my 10980XE, 4.8, 4.9 gigahertz on most of those 18 cores, not quite all of them, and that's a pretty awesome clock speed. Clock for clock, these systems are higher clocked cores than the E-cores that you'll experience in Alder Lake, but they are fast. And then you've got the performance cores that are just insanely way bananas over the top faster than what you have here. So the 16-core Alder Lake, it's not even a fair competition between the 10980XE for pretty much everything. Even though it doesn't have AVX 512, it will still give you a run for the money in terms of getting that actual computation done, unless you just specifically depend on AVX 512, because Alder Lake doesn't have that. These platforms, the other reason that people buy these is to get a lot of PCI Express connectivity for peripherals. Technically, Alder Lake has more PCI Express bandwidth. It doesn't have more lanes, but it has more bandwidth. When you add up the bandwidth from the 16 PCI Express 5 lanes for the GPU, 4 PCI Express 4 for the NVMe, and then 8 PCI Express lanes worth of bandwidth in the DMI 4.0 interface, that is more bandwidth than you'll experience on either one of these platforms. So I'm really hoping there's something in the pipeline that, gives us 28 or 40 performance cores and efficiency cores for really high-end workstations, but it seems like that's going to be a way off, and or Alder Lake has completely eaten away the market that is potentially available for these. If you need more PCI Express peripherals, they can be solved at the motherboard level. To take those PCI Express 5 lanes and break it out into 32 PCI Express 4 lanes. You can solve that problem on the motherboard side. But yeah, gaming performance and whatever else, if you got either one of these systems, Alder Lake just mops the floor with them. It's pretty crazy. So what does it look like when we go beyond 8 cores? Is it 300 watts, 350 watts? I mean, certainly I was pushing 330 watts when I was doing overclocking with the 12900K, but the performance offset in my mind, really wasn't worth it. That is a significant amount more power for not a lot more performance and quite a bit more instability. So your mileage may vary. And I don't know that I really recommend hardcore overclocking on the K parts. What the K means with the 12900K as opposed to like a previous i7, like say the 2600K, which is an overclocking champ, make no mistake, is that power curve, that power utilization, you get the 250 watts all the time. The first power phase is still 125 watts. So if you have a non-K processor, it's going to use and consume quite a bit less power, and it's going to run at reduced clocks as a result. With a K series SKU, as long as you can keep it cool, it's going to maintain those boost clocks basically indefinitely, at least according to the graph, and so far, anecdotally, according to my own experience, Windows 11 issues notwithstanding. Because the 690 motherboards are all over the place from what I can tell, I'm going to have a bunch of separate 690 motherboard video reviews as well, so make sure you get subscribed for those. The first 690 motherboard that I'm going to have a review of is this one from MSI. It's the one that I use for a lot of my testing, but I've got other reviews coming from all the big four motherboard makers. Don't worry, stay tuned. Do you need a $1,000 690 motherboard? The answer might surprise you. I mean, it's usually not yes, but stuff's happening. What about Threadripper and Threadripper Pro? Does that offer a challenge to Intel and Alder Lake, or are they themselves challenged? Mostly no, but potentially yes. We might be waiting until Meteor Lake, the thing that comes after Alder Lake, to really know for sure, but keep in mind Threadripper 3000 is almost 2 years old at this point. Threadripper 3000 series CPUs, the technology that's in it. With 32 cores versus 8 efficiency cores and 8 performance cores, it's not really a fair fight. Of course, in gaming, Alder Lake absolutely demolishes what you can get out of Threadripper and Threadripper Pro for high frame rate gaming. Bear in mind that you have to have the latest and greatest, very expensive GPUs in order to be able to do it. On the other hand, you could look at it in terms of power efficiency. I can pack in 32 cores at 4 gigahertz plus in about the same wattage that it's taking Intel to do 8 performance cores and 8 efficiency cores. But we'll talk more about performance per watt in just a minute. Overall though, I'm not really sure how much overlap there is in someone who is interested in the performance of Alder Lake, but is also interested in 32 to 64 cores in a desktop or workstation class platform. Who knows though? I've been trying to convince Intel for years that, hey, socket 3647 with 6 memory channels, it's not dead, I promise. Just make new CPUs that go in that socket, get with EVGA to get us some BIOS revisions and some updated firmware, and let's rock some really high performance, really high clock speed, crazy power delivery CPUs in socket 3647 on that platform. It's not dead, I promise, but, Anyway, so Intel claims that their processor is faster than the new M1. So we're rocking an M1, and, the performance there, everybody saw the Geekbench numbers, and the Geekbench numbers were crazy. And yeah, Alder Lake actually does beat those numbers, but one Alder Lake core is using almost as much power as the debut version of the entire M1 SoC. So Intel's got Alder Lake in terms of performance, but you wouldn't want an Alder Lake desktop CPU at desktop levels of power consumption in a laptop, because that's going to be 250 watts. And that brings us to a larger overall conversation about power efficiency. Does 8 performance cores and 8 efficiency cores combined for, a maximum power delivery of 250 watts, does that really matter in a desktop? Is that detrimental? No, I don't think so. There are already people that are rocking 280 watts plus for their CPU power usage for desktop, performance. And even the 11900K, Intel in their own marketing material is saying, okay, in our 10th and 11th gen, yes, that CPU could consume up to 250 watts. So yes, Alder Lake faster than the Mac M1, faster than the Mac M1 processor, even in like the iMacs that came out a little while ago, but at a significant power cost. And I feel like that the competition will probably respond a little bit in terms of performance. The 5950X, that's a TDP of 95 watts, but at peak, absolute maximum peak, it's going to draw on the order of 125, 135 watts overclocked, that kind of thing. But apples to apples, it's hard to do an apples to apples comparison when some of the apples are bananas, referring to performance cores and efficiency cores. And that is something that I've sort of echoed throughout this entire review. That said, at the risk of oversimplifying, Intel Alder Lake is about twice the power required per unit compute as AMD's 5950X. Again, on the desktop, I don't really personally think that's going to matter a lot, but in the enterprise space, that's going to matter a fair bit. So it's going to be interesting to see what Intel comes out with in their next generation. As power usage is potentially the biggest Achilles heel, the biggest downside for Alder Lake, Intel has really juiced the cores on Alder Lake to get as much performance as possible out of the silicon, and it's nice. I mean, it's really nice. It's nice to experience an Alder Lake system, but if power efficiency is something that's important to you, then this is something that should be on your radar. So there you have it. Alder Lake is launched. Availability, probably going to be a concern, at least based on what my contacts at retail have been telling me. I mean, some of the CPUs have actually already shipped, even days and days ahead of this review. Some stuff's been published online because, hey, I just ordered some stuff on Newegg, and it literally arrived before the embargo was up. So some of my stuff is from retail, from Newegg. Some of my stuff is from partners. MSI, in particular, really saved my bacon on this review in terms of getting me performance parts and reviews and sort of helping me troubleshoot some things. Windows 11 was also a little bit of a wild card here. In general, if you get it set up correctly, Windows 11 will offer about a 4.5% performance improvement over Windows 10 on Team Red. Now, on the Intel platform, because of the scheduler changes we talked about earlier, you really need Windows 11 for Alder Lake. It can work on Windows 10, but you really need Windows 11 for Alder Lake. And if you're interested in Linux, be sure to check out the Linux channel for the full review on Alder Lake on Linux. Had a lot of problems and adventures there too, let me tell you. Mostly, it's just new platform teething issues. You remember the X299 launch? It's like the X299 launch all over again. Now, Intel, for its part, I don't think is doing anything shady or underhanded here with the benchmarks or the reviews or anything else. They're just trying to put a product out there that is a hybrid architecture, which is their answer to all things in the market. And really, the weakest link of Alder Lake is the power usage. But the fact that it's a hybrid design and all sorts of fun stuff, that is really exciting, especially for the mobile space. I'm still a little bit not sure about hybrid design in a context of a desktop computer that's plugged into the wall all the time because, you know, the $5 a year and electricity difference, does that really matter to anybody? I don't know. Mobile, certainly, yes. You can pack better battery life, longer battery life, that kind of thing. So the jury's still out on that for me. Maybe you can, let me know what your thoughts are. Let me know what you think below, but I don't know. That's really the biggest downside for Alder Lake. And oh boy, that single thread performance is head and shoulders above everything else that Intel has. It is amazing how far over it is, even on the 11th gen Core i9, even with an overclock, even rocking 5.3 gigahertz thermal velocity boost. It's crazy. Also, in stark contrast to how things have been in the past, Z690, the motherboard variation for Z690 is going to be fairly significant if what I'm reading is true about how the VRM works and how power delivery is going to work. So not all Z690 motherboards are created equal. Be sure to look out for our Z690 motherboard reviews because you might get a motherboard review that you pair with the wrong processor and maybe the performance won't be there. I don't know yet though, because weirdness. So I'm Wendell, this is level 1. This has been the quickest look I know how to do at Alder Lake. And I think the i5 is more the game changer than the i9 because if you look at, the $300 5600X and you're looking at your 10 core, Alder Lake i5, if the motherboard cost is roughly the same and everything else is at parity, that i5 processor is in a completely different class. It'll be interesting to see how AMD responds. I'm Wendell, this is level 1. I'm signing out. You can find me in the level 1 forums.